Good afternoon. We are going to discuss about topic gravitation. There is a two kind of statement about gravitation. One is Newton. Newton said gravitation is a force of attraction between two masses. Einstein. Einstein said gravitation is a space-time curvature. We will restrict ourselves up to Newton, which means it's a force of attraction. Gravitation, in another way we can say, it's a fundamental interaction between matter. Which means we humans interact with other human by speaking, right? Similarly, we are using gesture for communication purpose. Sometimes instead of us, we can use sign language for a communication purpose. These are a kind of interaction. Animals also interact in their own way by making some noise. They cannot talk, but they can interact with other animals by making some noise, right? So these are living creature. But in the universe, there are non-living creature also exist. They also interact in their own way. One way is gravitation. Source of interaction. What is the source for this interaction? Mass itself. Mass. If there is a mass, there will be an interaction between two bodies. I will directly go to universal law of gravitation. As per Newton's law of gravitation, each body in the universe attract every other body. Each body in the universe attract every other body, which means there is a force of gravity between Earth and Moon. Force of gravity between Earth and human, and a force of attraction between two humans. Force of attraction between human and water bottle, which means there is attraction force between each and every masses in the universe. The attraction force directly proportional to product of two masses. Let's take a mass m1, m2 separated by distance r. Here, this distance is center to center. Center of mass m1 and center of mass m2. For simplification purpose, we are assuming spherical body. And these two must be a point mass. What is point mass? Let's take a diameter of mass 1 is d1 and diameter of mass 2 is d2. These are much greater than d1 and d2. In this case, we can consider two masses as a point mass. This attraction force between these two masses directly proportional to product of the two masses m1 into m2 and inversely proportional to square of distance between them, which means directly proportional. When mass increases, force of attraction increases. Okay, when distance increases, force decreases. Directly proportional, which means when one quantity increases, another quantity also increases. Inversely proportional, which means when one quantity increases, another quantity decreases. So force directly proportional to product of the two masses and inversely proportional to square of distance between them. We are combining both. We are getting equation F proportional to m1 m2 by r square. Wherever there is proportionality, we have to introduce constant to cancel the proportionality. F, which is equal to capital G m1 m2 by r square. Here the capital G, it is universal gravitational constant, which means the value of capital G remains constant in the universe everywhere. 6.67 into 10 to the power minus 11 Newton meter square by kilogram square, which means I have a two masses m1 m2, distances r1. These are fixed. M1 is fixed, M2 is fixed, distance between them is fixed. Now we are measuring force between them is 10 Newton. It is at surface of earth. It is surrounded by air. Now I will dip this setup into water. It is surrounded by air now. Now I will dip this setup into water. Now we are measuring force again, provided m1, m2 r must be fixed. So again force is 10 Newton. Initially we measured force in water, air, we got a 10 Newton. Now we are changing the setup. Again we are getting 10 Newton. Now I'll shift this setup to vacuum, which means there is no atmosphere surrounded by it, which means there is no air. Everything is empty in between. Even in that place also we are getting force as 10 Newton if we measure. Now I will change this setup into surface of moon. M1 is fixed, M2 is fixed, and R is fixed. When I shift this setup into moon, there also we are getting same amount of force. Or if I shift this setup to interstellar space, which means there is no other celestial body nearby, there also we are getting 10 Newton, which means gravitational force between two body does not depend upon the surrounding or presence of other body. It is purely depend upon those two bodies and distance between them. Unlike gravitational force, the electric force and magnetic force depend upon medium. Here electric constant epsilon, magnetic constant mu, these two are depend upon medium, like electric force maximum in vacuum, magnetic force maximum in medium. So these are variable. Different medium possess different value, but capital G remains constant everywhere in the universe. Now, this forces vector quantity. Generally, forces vector quantity. We defined magnitude of force. Now, we can define direction of force. Now, the direction of force acts along the line joining these two center of masses. Let's say this is a body 1, this is m1 and 2. It's a kind of tug of war. The force acting along the line joining these two center of mass. Let's say this is a force acting on 1, 2. This is a force acting on 2 by 1, which means F12, which means force on 1 by 2 in this direction, F12, F21 in this direction. And this law of gravitation obeys Newton's third law. What is Newton's third law? Every action has equal and opposite reaction, and reaction must be same nature, and it should act in different bodies, which means if I consider for a body 1 action reaction, for a body 1 action is F21, reaction is F12. If I consider 2, my action is F12, reaction is F21. Both are equal in magnitude, opposite in direction. They are acting in different bodies and they are in same nature. When I write vector wise, F12 negative of F21. Okay. Let's go for some question. F is equal to G M1 M2 by R square. Now, let's take a condition. There is a body M1, M2. They are identical, which means identical mass, identical radius, identical density. They are separated by distance r, small r. Now, they will attract. Okay, another case M1, M2. Another case, here is distance r. Here touches each other. Here they are not touching each other. Here, in a case when two identical bodies separated by distance r, they are touching each other. Now, in case 2, identical body, they are not touching each other, the distances are. Now, we are increasing the distance between them, or we are decreasing the distance between them. In case 1, while increasing distance, the condition is they should touch each other. Whether we are increasing the distance or decreasing the distance, that doesn't matter. They should touch each other. In this case, what is the relation between this force and R? What is the relation between force and R? We have to find. What is the relation? Whether inversely proportional or directly proportional. If I take a case 2, when I increase the distance, the only variable here distance only, because there is no other condition. When I increase the distance or when I decrease the distance, M1, M2 remains same, R is variable, which means here I can clearly say force inversely proportional to R square because M1, M2 remains same. But in this case, in case 1, while increasing the distance between them or decreasing the distance between them, they should touch each other, which means let's try to increase the distance. When I increase distance between them, what's happening here? Their size also increases, which means mass increases. Here, mass also a variable, which means we cannot directly say whether R is directly proportional to R square or inversely proportional to R square because there are one more variable, mass also variable. Now we can convert everything into one variable. Let's say density of sphere is rho. This is my M1, this is my M2. Radius is R, since identical, which is R. This is my 2R, small r. My small r is equal to 2 times of capital R, radius. Now, what is the equation now? F is equal to G M1 M2 by R square. M1, mass of first sphere. I can write density into its volume, 4 by 3 pi R cube. And second sphere, M2, density into 4 by 3 pi R cube. And small r square. I can write capital R as small r by 2. Now, F is equal to G rho 4 by 3 pi square, and capital R I can write small r by 2, small r by 2 whole power 6 divided by r square. So we are getting now G rho into 4 by 3 pi the whole square r power 6 divided by 64 into r square. I can cancel. Now I am getting the terms G into rho 4 by 3 pi whole square 1 by 64 into r power 4. Here, except smaller, remaining terms are constant, which means now I can say the attraction force between them, directly proportional to r power 4. Which means what is the condition here? When those spheres are touching each other, in that case, the attraction force between them directly proportional to r power 4. Okay. Now, let's take one more question. There is a body which mass is capital M. Now, I'll transfer a certain amount of mass from this body. I'll transfer a certain amount of mass. Let's say x amount of mass. I'll transfer here. Now, we have two bodies. We are keeping at a distance smaller. Now, for what value of x, force between them is maximum. Now, when I transfer certain amount of mass, we are getting two bodies, there will be a force of attraction. Definitely for certain amount of mass, there will be certain maximum force. We have to calculate that mass. Here, my remaining mass is m minus x. Here is x. This is a distance, r. This is my m1. This is my m2. Now, I'll write an equation. F is equal to capital G m1 m2 by r square. So, capital G, what is my m1? Capital M minus x. m2 is x by r square. Here, only variable is x. In a single variable function, when we differentiate a function and equate it to 0, we will get either maximum or minimum. So, df by dx, which is equal to g by r square, and m minus x, differentiation of x is 1, plus x, differentiation of m minus x is 0 minus 1. When I equate it to 0, I am getting m minus x, which is equal to 0, which means px is equal to m. So, it's the value of x here, m by 2, which means when we transfer 50% of mass, in this case, force between them is maximum. Okay. Let's take a term small g. Acceleration due to gravity at a planet surface g m by r square. M is, we have a planet having mass m and radius r at surface. Acceleration due to gravity at surface is equal to j m by r square. This value is maximum at surface. When you go higher altitude, it is decreasing. When you go inside, it is decreasing. When we move from equator to pole, g increases, which means the value of g maximum at the surface at poles. I'll take a result and discuss few questions. Now, we are going inside to the earth. This is a earth, radius r. Now, we are going certain depth inside. This is my d. G at this depth, which is equal to g at surface into 1 minus d by r. Now, in case if I measure distance from center, this is from center, x. G with respect to x. G at surface into x by r. Now, my question is, I have earth, there is center of earth. I'll dig a tunnel towards center to other side. This is a tunnel. We have a tunnel towards center of earth up to other side. Now, I'm placing a body at a surface. What will happen? It will accelerate, which means when I release a body here, it will accelerate in this direction. So, velocity increases. When it reaches center, what will happen? At center, acceleration is 0. So, it will have maximum velocity. At this point, V max. Once it crosses the center, what will happen? The body will move in this direction, but acceleration will act in this direction, which means here velocity decreases. At the end, it will reach this point, velocity becomes 0, which means it will execute simple harmonic it will execute oscillation. When released at topmost point, it will accelerate continuously down towards center. Up to center, velocity increases. Once it crosses the center, velocity will decrease. Why? Because velocity and acceleration both are in opposite direction, which means there is oscillation. Now we are going to calculate time period of this oscillation. So there is a tunnel. Here is the center. This is a distance x from center. Now acceleration here I am writing as a. Instead of g I'll write as a. Now this is my direction of acceleration. What is my a here? Acceleration at surface into x by r. Now if we observe, acceleration and displacement both are in opposite direction. This is my direction of acceleration. This is my direction of x, means it is exactly in opposite direction. At the mean position, x is 0, a is 0. If I take extreme position, this is my extreme. When from mean position, when I move upward, my x value towards up, but my a value remains towards down. Which means here acceleration directly proportional to displacement, and also it is acting opposite to the direction of displacement, which means this is simple harmonic motion. In simple harmonic motion, acceleration directly proportional to displacement and acting in opposite direction. So here a is equal to minus omega square y. What's omega square here? G by r. What is omega here? Square root of g by r. What's the time period? 2 pi by omega. We are getting square root of r by g. For earth, r is 6.4 into 10 to the power 6. G is 9.8. If I calculate, we'll get a value as 85 minutes. Now, same question, we are changing the case. Now, we are digging a tunnel which is not passing through center. This is a tunnel. It is not passing through center. It is passing through some other curve. It's not a diameter. Again, here also we are releasing a body. What will happen? Similar way, it will accelerate till this point. After when it crosses this point, it will decelerate. Which means here also it will execute oscillation. Now we are going to calculate time period here as well. Here is my center. I'll make big diagram. This is my tunnel. This is a radial vector. Okay, I'll choose a point. This is a point. This is a distance x. And this is theta. Now, this is the direction of acceleration of a body. This is the direction of acceleration of a body. I'll measure this distance as y. I'll draw this triangle here. This is my x. This is my y. This is my theta. Now, this is my direction of g in this point. Okay. Here, g at surface into x by r. This is my radius. This is my radius. This is my direction of radial vector. So g at this point, I'll note a point as O at this point. At point O, g at surface into x by r. Now we need acceleration in this direction. When I resolve this, this is my A which is equal to G, this is theta, this is 90 minus theta, G of cos 90 minus theta. Cos of 90 minus theta, we are getting sin theta. So what is sin theta here? Opposite by hypotenuse. Opposite is my y, hypotenuse is x. What is G here? G at surface into x by r into y by x. This will be cancelled. So we are getting A is which is equal to G at surface into y by r. Here also, see, this is my direction of y, but this is my direction of e. Both are in opposite direction. So my acceleration vector is equal to gs by r into displacement vector. They are in opposite direction. Here g and r constant. Only variable is y itself, which means here also acceleration directly proportional to displacement and it is acting in opposite direction, which means my motion here is simple harmonic motion. Again here omega is equal to square root of g at surface by r, t is equal to 2 pi into square root of r by g at surface, getting same thing as 85 minutes. Okay, this 85 minutes has some importance. Now let's take a planet, let's take a satellite which is revolving around earth, close to earth. This is the radius of earth, capital R, and the mass of earth here. We have a satellite